Okay, for the next section, 29 through 31, use inductive reasoning to determine the next item in the pattern. So remember that inductive reasoning is what I think, I see, I observe. It's all about patterns. And so let's look at number 29. This is not, this is 4, 3, 6, 5, 8. This is not increasing a steady amount or decreasing a steady amount. In fact, it's going up and down. So let's look at this. How do I go from 4 to 3? I decrease 1. But then all of a sudden I increase from 3 to 6. I'd have to add 3. And then from 6 to 5, decreases 1. And then from 5 to 8, that increases 3. So this looks like a continuing pattern. So what would be our guess? What is 8 minus 1? That would be 7. So our next item in the pattern would be 7 based on that pattern. All right, number 30, 2 to negative 4, to 6 to negative 8, to 10. So the first thing I notice is that these numbers are even, 2, 4, 6, 8, 10, and that every other term is alternating as a negative number. So 2, 4, 6, 8, 10. Many of you will quickly say 12. We just have to make sure that we throw a negative in front of it because we are alternating positives and negatives, and we are doing the even numbers. Number 31 is our triangles. Think back to the day we did this, our triangles. So if on your study guide these dots aren't super visible, please darken those for me. And so these are all triangles. And we're looking at this pattern. We're trying to see where the ball will go next. So it's bottom right, bottom left, top. Bottom right, if we continue in that same clockwise pattern, where will it go? So it just was at the bottom right. We're following this one 1 to 2. So 4 to 5 will be bottom right, will be bottom left. Okay? So we will have a dot. Oh, goodness, I'm not sure what just happened on that. We'll have a dot in the bottom left. It's just that dot is going clockwise around this triangle, so bottom left. That just asks for the next item in the pattern, not the 10th like it did on our notes. All right, we want to circle the hypothesis, and then we are going to underline the conclusion of each statement. So remember that these are if-then statements. So what I like to do is I like to go ahead and find the word if and then on all of these. There's the word if on 33, if on 34, then. There's no then on 33 because you don't start a sentence with the word then. There's no if and there's no then in number 35, okay? But it does say when, and we can use that interchangeably with the word if, okay? So it says when. So if you are a lawyer, okay? So circle the hypothesis. This will be my hypothesis. You are a lawyer would be the hypothesis. What is the conclusion? You passed the bar exam. So here's my P, here's my Q. You are a lawyer, then you passed the bar exam. Okay? All right? But this next one starts with the conclusion, and it leaves out the word then because we don't include that at the beginning of a sentence. You like to play games. That's our conclusion. If, what has to happen if you like to play games? You signed up for a gaming club. And so that is our hypothesis. If you signed up for a gaming club, what is our conclusion? Then you like to play games. So conclusion is that you must like to play the games if you signed up for the gaming club. So this causes this to happen. Okay? Whereas this one's written in if-then form, where you've got your hypothesis first and then your conclusion. I did not do what it asked me to do. It said to circle it, so let's circle that instead. Okay? All right. If it is a fish, that's our P. What is our Q? It lives in water. So again, it does not include the word if. It does not include the word then. There's our P and then our Q. And then again, here's our it's a crazy day. When is it a crazy day? What has to happen to make it a crazy day? If there's a pep rally, which there is this Friday, my friends, we are so excited to go head back to the main campus for our pep rally. So it is a crazy day when/if there is a pep rally. So that happens and it makes it a crazy day. All right, identify a counterexample for each statement. And it's multiple choice on this first one. So if 1 and 2 are supplementary, then one of the angles is acute. So we're looking for supplementary, which means that they add up to 180. So if I'm looking for a counterexample, it has to be true for the first part, but it has to fail the second part, meaning that they're not acute. So which of these can I immediately get rid of? B does not add up to 180, so that is not going to be a counterexample. D does not add up to 180, so that's not going to be a counterexample. It has to make the first thing true, but it has to fail the second thing. Okay, so we're looking for an example where they add up to 180, but one of the angles is not acute. So 120 and 60 would satisfy the first one. They do add up to 180, but then the 60 is the acute. So that is not a counterexample. That is an example. That makes it work. So what's a counterexample? A counterexample on this problem would be A, 90 and 90, because 90 and 90 are supplementary. 90 plus 90 do, in fact, add up to 180. But between 90 and 90, neither of those are acute. So that would be a counterexample that disproves the statement. If the month starts with the letter J, then it's a summer month. So like June and July would be examples that make you think that that might be true. What's a counterexample? The month of January starts with the letter J, but it is not a summer month. Number 38 says if a number is a multiple of 5, then it is a multiple of 10. So a number is a multiple of 5, then it is a multiple of 10. They make this multiple choice, but then they also ask you for a counterexample. We'll just list it in both spots. So we want it to be a multiple of 5, so it has to be the case to make it true. Are any of these not multiples of 5? No, all of these fit the script for multiples of 5. But which one is not a multiple of 10? 50 is a multiple of 10. 30 is a multiple of 10. 40 is a multiple of 10, but 25 is not a multiple of 10. So which one is the counterexample? C, which was 25. You could come up with other counterexamples, 55, 35, 15, all of those would work. Multiples of 5, but not multiples of 10, so that discredits the statement. And I will do a new video for this next section.